You spent $1,500 on a gaming PC, maybe $2,000. The listing promised smooth gameplay, high frame rates, and a system that could handle anything you threw at it. You unboxed it with genuine excitement. You fired up your first game, and within minutes, something felt off. The frame rate stutters. Loading times drag on forever. Your friends with supposedly weaker systems are somehow getting better performance than you. You start questioning everything. Did you get scammed? Is your GPU defective? You check the specs again. RTX 4070, Ryzen 7, 16 gigs of RAM. On paper, this thing should be crushing games. But it's not. And here's what nobody tells you when you buy a pre-built gaming PC. Your graphics card is probably not the problem. In fact, I'd bet money that your GPU is working exactly as it should. The real culprits are hiding in plain sight, quietly strangling your system's performance, and most people never figure out what's actually wrong. And the number. One killer I'm going to reveal at the end of this video is so dangerous that it could be slowly destroying your entire system right now without you even knowing it. By the end of this video, I'm going to show you 5 reasons your expensive gaming PC feels like it's running through mud, and the number one issue on this list is so common and so devastating that it's probably affecting your system right now. Let me explain something that pre-built manufacturers desperately don't want you to understand. Building a gaming PC isn't about cramming in the most expensive GPU and calling it a day. It's about balance. It's about making sure every component in your system can actually keep up with every other component. When you buy a pre-built, the company building it has one primary goal: maximize their profit margin while making the spec sheet look impressive enough to justify the price tag. This creates a fundamental problem. They'll spend money on the parts you're paying attention to, the GPU and the CPU, and then they'll cut every possible corner on the parts you're not looking at. They know most buyers don't understand the difference between single-channel and dual-channel RAM. They don't expect you to check what kind of power supply is actually inside the case. They're betting on the fact that you won't notice the thermal paste was applied by someone who clearly didn't care about your temperatures. And this imbalance, this invisible network of bottlenecks and compromises, is exactly what's killing your performance. Your system is only as fast as its slowest component. You can have the best GPU money can buy, but if it's being strangled by a cheap power supply, terrible airflow, or misconfigured RAM, you're going to feel like you wasted your money. So let's talk about the 5 hidden problems that are absolutely destroying your gaming experience. Number 5. Your RAM is running in single-channel mode, and you have no idea what that even means. Let me paint you a scenario. You boot up Cyberpunk 2077. The game loads, eventually, and you start playing. Within 10 minutes, you notice something strange. Your frame rate is fine when you're standing still, but the second you start moving through the city, everything stutters. Not a clean drop from 60 frames per second to 50. It's this horrible, jarring stutter where the game freezes for a fraction of a second, catches up, freezes again. You drop all your settings to medium. The stuttering persists. You're confused because your GPU usage is only sitting at 70%. It's not even fully loaded, but the game still feels terrible. Here's what's actually happening. Your pre-built came with a single 16 GB stick of RAM instead of 2 8 GB sticks. This is one of the most common and most destructive cost-cutting measures in the entire industry. When RAM runs in single-channel mode, your CPU can only talk to one stick at a time. Imagine trying to fill a swimming pool, but instead of using 2 hoses, you're using 1. It takes twice as long. Your CPU is starving for data. It's waiting on that single RAM stick to feed it information. And while it's waiting, everything else in your system is sitting idle. This creates micro-stutters. Frame time inconsistency. A gameplay experience that feels fundamentally broken no matter what settings you use. The fix is straightforward, but requires you to buy another stick of RAM. You need to match the exact specs of the stick already in your system. Same speed, same timings, same brand if possible. If you have a single 16 GB stick of DDR4 3200, you need to buy another identical stick. Corsair Vengeance, G.Skill Ripjaws, Kingston Fury, doesn't matter which brand as long as you're matching the specs. Install both sticks in the correct slots. Your motherboard manual will tell you which ones usually slots. 2 and 4. Boot into BIOS. Enable XMP or DOCP depending on your motherboard manufacturer. Your RAM will now run in dual-channel mode, and I'm not exaggerating when I say this can improve your 1% lows by 30 to 50% in CPU-bound scenarios. The difference is night and day. If you're running DDR5, the same principle applies, but it's even more critical because DDR5 is designed from the ground up to perform better in dual-channel configurations. A single stick of DDR5 is leaving a staggering amount of performance on the table. But RAM isn't the only storage component secretly killing your performance, and what I'm about to show you next causes problems that most people blame on their GPU. Number 4, your SSD is cheap, slow, or installed in the wrong slot, and it's murdering your load times and causing stutters you think are GPU related. Picture this: you're playing Starfield. The game has to stream textures and assets constantly as you move through massive environments. Every time you enter a new area, there's this terrible pause. The game freezes for 2 or 3 seconds. When it unfreezes, textures take forever to load in. You're staring at blurry walls for 10 seconds while the game catches up. You assume this is just how the game runs. Everyone complains about Starfield's performance, right? Except your friend with a similar system doesn't have this problem at all. Here's the reality. Your Prebuilt came with the absolute cheapest SSD the manufacturer could source. Not all SSDs are created equal. There are SATA SSDs, which are old technology running on an outdated interface. There are NVMe Gen 3 drives, which are significantly faster, and there are NVMe Gen 4 drives, which are faster still. Modern games are increasingly designed around fast storage. Direct storage technology in Windows 11 is supposed to let your GPU load assets directly from your SSD without involving the CPU. But if your SSD can't keep up, the entire system bogs down. You get texture pop-in, you get stutters, you get load times that feel absurdly long. Worse, even if you have a decent NVMe drive, your Prebuilt might have installed it in the wrong M2 slot on your motherboard. Most motherboards have multiple M2 slots, but not all of them run at the same speed. The first slot usually connects directly to the CPU and runs at full Gen 4 speeds. The second or third slot might run through the chipset and be limited to Gen 3 speeds, or worse, share bandwidth with your SATA ports. If your SSD is in the wrong slot, you're leaving performance on the table. Open up your case and check. Your motherboard manual will tell you which slot is the fastest. If your drive is in a secondary slot, move it to the primary. If you need to upgrade entirely, you want something like a Samsung 980 Pro, Western Digital Black SN770X, or Crucial P5 Plus. These are Gen 4 NVMe drives with actual DRAM cache, not cheap DRAMless drives that slow to a crawl under sustained loads. Install it in your primary M2 slot. Clone your existing drive using software like Macrium Reflect. Boot from the new drive. The improvement in game load times and asset streaming will be immediately obvious. This isn't a minor tweak. This is fundamental to how modern games function. Now, fixing your storage helps, but there's a silent killer inside your case that gets worse the longer you play, and it's sabotaging every component we've talked about so far. Number 3. Your Prebuilt has absolutely abysmal thermals, and your CPU or GPU is throttling itself to avoid melting. Let's walk through what this looks like in real usage. You start playing Call of Duty. For the first 5 minutes, everything is perfect. Smooth frame rates, no issues. Then, gradually, you notice the performance degrading. Your frame rate drops from 120 FPS down to 90, then 80, then it sits at 70 and refuses to go higher. You're not changing settings, you're not doing anything different. The game is just getting slower the longer you play. You touch the side of your PC case, and it's almost too hot to keep your hand there. What you're experiencing is thermal throttling, and it's one of the most common problems with pre-built systems. Here's how it works. Your CPU and GPU have maximum temperature limits. When they hit those limits, usually around 90 to 100 degrees Celsius, they automatically reduce their clock speeds to prevent damage. Lower clock speeds mean lower performance. Your expensive components are intentionally slowing themselves down because they're overheating. Pre-built manufacturers cut corners on cooling in truly breathtaking ways. They use the cheapest possible CPU cooler. They install the bare minimum number of case fans. They route cables in ways that block airflow. They use thermal paste that's either poorly applied or low quality. They cram everything into cases with terrible ventilation. Some pre-builts ship with a single exhaust fan and literally nothing else. The result is a system that looks fine on a spec sheet but runs like a space heater under load. Download HWinfo 64 or MSI Afterburner. Run it while gaming. Watch your temperatures. If your CPU is consistently hitting 90 degrees or higher, you have a cooling problem. If your GPU is hitting 85 degrees or higher, same issue. The fix depends on how bad it is. Start with the easy stuff. Add more case fans. You want at least 2 intake fans at the front and 1 exhaust fan at the rear. Positive air pressure, more air coming in than going out, keeps dust from accumulating and improves overall thermals. If your CPU cooler is a tiny stock cooler that came with your processor, replace it immediately. Something like a Thermalright Peerless Assassin Deepcool AK620, or be quiet. Dark Rock 4 will drop your CPU temperatures by 20 to 30 degrees. These are tower coolers under $50 that perform as well as many liquid coolers. If you're more adventurous, repaste your GPU. This requires disassembly and careful work, but factory thermal paste can dry out or be poorly applied, and fresh paste can drop GPU temperatures by 10 degrees. Better thermals mean your components can maintain their maximum clock speeds. Higher sustained clock speeds mean better performance. This is especially critical in longer gaming sessions where thermal buildup becomes a serious problem. But even with perfect temperatures and fast storage, there's an invisible layer of software sabotage happening right now that's eating your performance alive. And remember, we still haven't reached the #1 problem yet, the one that's actually dangerous to your hardware and could cost you way more than just lost frame rates. Quick reminder, if this video is helping you out, hit like and subscribe. It really supports the channel. Number 2. Your Windows installation is a disaster, your BIOS is misconfigured, and your system is running with one hand tied behind its back. This is where things get truly frustrating because these problems are invisible until you know where to look. Imagine you're playing Elden Ring. You're getting decent frame rates, but something feels wrong. The game doesn't feel smooth, even though your FPS counter says 60. There's input lag. Your mouse movements feel sluggish. When you pan the camera, there's this weird stuttering that makes you slightly motion sick. You've tried every in-game setting. Nothing helps. The problem isn't the game, it's your system configuration. Pre-built manufacturers install Windows with all kinds of bloatware. Trial antivirus software running constantly in the background. Manufacturer-specific utilities you'll never use. RGB control software that's poorly coded and eating CPU resources. Telemetry services phoning home. Every single one of these programs is stealing system resources. They're using CPU cycles, RAM, and disk bandwidth that should be going to your game. Even worse, Windows itself has performance-killing features enabled by default. Game mode sounds helpful, but it can actually cause stuttering in certain scenarios. Hardware-accelerated GPU scheduling might or might not improve performance depending on your specific hardware. Windows Update might decide to download updates in the background while you're gaming. Your power plan might be set to balanced instead of high performance, which means your CPU isn't allowed to run at full speed. Then there's your BIOS. Your motherboard has dozens of settings that affect performance, and pre-built manufacturers often leave them at conservative defaults. XMP or DOCP profiles for your RAM might not be enabled, meaning your expensive high-speed RAM is running at standard JEDEC speeds. Your CPU might not have Precision Boost or Turbo Boost properly configured. Your PCIe slots might be running at Gen 3 speeds instead of Gen 4. Resizable bar, a feature that lets your CPU access your entire GPU memory at once, might be disabled. Each of these individually seems minor, but collectively they're suffocating your performance. Here's what you need to do. Clean install Windows. Back up anything important. Create a Windows installation USB using Microsoft's Media Creation tool boot from it, and do a completely fresh installation. Don't use the recovery partition that came with your Prebuilt. That's full of bloatware. During installation, don't sign in with a Microsoft account if you want to avoid some of the telemetry. Once Windows is installed, only install the drivers you actually need from your motherboard manufacturer's website and your GPU manufacturer's website. Nothing else. No bloatware, no trial software. Then optimize Windows. Set your power plan to high performance or ultimate performance. Disable unnecessary startup programs using Task Manager. Turn off game, bar and game mode. Enable hardware-accelerated GPU scheduling if you have a modern GPU. Disable Windows search indexing on your game drive. Boot into BIOS. Enable XMP or DOCP for your RAM. Enable resizable BAR if your CPU and GPU support it. Set your PCIe slots to Gen 4 if your motherboard and GPU support it. Make sure your CPU boosting is properly configured. Update your BIOS to the latest version, but only if you're comfortable doing so. These changes won't show up as a massive FPS increase in benchmarks. What they do is eliminate stuttering, reduce input lag, and create a smoother overall experience. Your frame times become more consistent. The game feels more responsive. This is the difference between a system that technically performs well and a system that actually feels good to use. Everything we've covered so far can hurt your performance, but what I'm about to reveal is the single component that can actually kill your entire system if you ignore it. This next problem is the one manufacturers hide the most aggressively, because if people knew how bad it was, nobody would buy their systems. Number 1, your power supply is cheap, underpowered, or straight up failing, and it's the single biggest performance killer that nobody talks about. This is the problem that makes me genuinely angry at pre-built manufacturers because it's so predatory and so common. Let me describe what this looks like in the real world. You're playing a demanding game like Hogwarts Legacy or The Last of Us. The game runs fine at medium settings. You decide to push it. You max out the graphics settings. Within minutes, your screen goes black. Your entire system shuts down. No warning, no error message, just instant power off. You turn it back on, confused and frustrated. You try again with slightly lower settings. This time, it runs for 20 minutes before shutting down again. You start to panic. Is your GPU dying? Is something fried? You run stress tests. Your components pass. Everything seems fine until you actually try to game. Here's what's happening. Your power supply can't deliver the wattage. Your system is demanding. When your GPU ramps up to full load, when your CPU boosts to maximum frequencies, when everything is drawing power simultaneously, your PSU hits its limit and simply gives up. It triggers overcurrent protection and shuts down to prevent damage. This isn't just a pre-built problem, but it's extremely common in pre-builts because manufacturers skimp on PSUs more aggressively than almost any other component. They'll install a power supply that technically has enough wattage on paper, but it's from a no-name brand with terrible efficiency, poor voltage regulation, and components that can't sustain their rated output. Or they'll underspec it entirely. Your RTX 4070 and Ryzen 7 systems should have a quality 750-watt power supply at minimum. Instead, your pre-built came with a 600-watt unit from a brand you've never heard of. Even if it doesn't shut down, a weak or failing PSU causes invisible problems. When your GPU requests more power and the PSU can't deliver, clean, stable voltage, your GPU automatically clocks down to compensate. This is called power limiting, and it absolutely kills performance. Your GPU knows it can't draw the power it needs, so it reduces its frequencies to stay within the available power budget. You look at your monitoring software and see your GPU running at 50% power draw when it should be at 90%. That's not a GPU problem, that's a power supply problem. Ripple, voltage fluctuation from a low-quality PSU can cause instability, crashes, and even permanent damage to your components over time. This is legitimately dangerous. A failing PSU can take your entire system with it. Diagnosing PSU issues is tricky because the symptoms mimic other problems. Random shutdowns could be overheating or could be PSU. Underperforming GPU could be thermal throttling or could be power limiting. The most reliable way to check is to monitor your system with HWinfo64 during heavy gaming. Look at your GPU's power draw. If you have an RTX 4070, it should be pulling 200 watts or more at full load. If it's sitting at 150 watts and your temperatures are fine, you have a power delivery problem. Check your 12-volt rail voltage. It should stay between 11.4 and 12.6 volts. If it's fluctuating wildly or dropping below 11.4 under load, your PSU is struggling. The solution is unambiguous. Replace your power supply immediately. Don't cheap out on this. A quality PSU from a reputable brand is the foundation of a stable system. Corsair RM Series, Seasonic Focus, EVGA Supernova, MSI MPG, or Be Quiet Straight Power are all excellent choices. You want 80+ gold efficiency at minimum. You want fully modular cables, so you only connect what you need. You want a wattage rating that gives you headroom. For a modern mid-range gaming system, 750 watts is the sweet spot. For high-end systems with power-hungry GPUs like the 4080 or 4090, go for 850 or 1000 watts. Yes, this is an investment. A good PSU costs between $100 and $150. But it's the one component that powers everything else. It's the difference between a system that crashes randomly and a system that runs flawlessly. It's the difference between being scared to max out your settings and confidently pushing your hardware to its limits. And if your current PSU is truly failing, it's the difference between a working computer and a very expensive pile of damaged components. Here's the fundamental truth that ties all of this together. Your gaming PC isn't slow because you bought the wrong GPU. It's slow because it was built by people who prioritize profit margins over performance. They gave you the specs that look good in an advertisement and cut every corner they could on the parts you wouldn't notice until it was too late. Single-channel RAM, cheap SSDs in the wrong slots, inadequate cooling, bloated software and misconfigured settings, garbage-tier power supplies that can't actually deliver what your system needs. Each of these problems individually can cripple your performance. Together, they create a perfect storm of disappointment where a $2,000 machine feels worse than your friend's $1,500 custom build. The good news is that almost all of these issues are fixable. You don't need to throw out your entire system. You need to identify the weakest links and address them methodically. Add another RAM stick. Upgrade your SSD. Improve your cooling. Clean install Windows and configure your BIOS properly. Replace that terrible power supply with something that actually works. Each fix builds on the others. Better thermals let your components run at higher clocks. Dual-channel RAM feeds your CPU faster. A proper PSU lets your GPU pull the power it needs. Clean Windows reduces background overhead. These aren't separate problems. They're interconnected bottlenecks, and fixing them transforms your system from a sluggish disappointment into the gaming machine you thought you were buying. Here's something most people don't realize. Fixing even just 2 or 3 of these issues can make your system feel like you upgraded your GPU without spending a single dollar on graphics cards. I want to hear from you. Drop your full system specs in the comments. Tell me what problems you've been experiencing. Let's figure out which of these issues is affecting you, because I guarantee at least one of them is. And if you've already fixed any of these problems in your own system, share your experience. Help other people avoid the frustration you went through. Building and maintaining a gaming PC is a learning process, but once you understand what's actually holding you back, the solutions are straightforward. Your expensive gaming PC doesn't have to feel slow. You just need to stop letting manufacturers get away with cutting corners on the parts that matter.